Hi, I'm Ben Summers, Director of Microsoft 365 Platform Marketing here at Microsoft.
And I'm Michael Moore, Principal Partner Solutions and Technology at Neo4j.
Today, we're talking about how to use Microsoft Graph and Neo4j technology to understand enterprise communications. To kick things off, let's take a minute to talk about Microsoft Graph. Graph is a rich source of data that's built around relationships with people and groups in Microsoft 365. It's the container for all the data that describes the patterns of productivity, collaboration, identity, and security in an organization. You might even go so far as to say it's the digital twin for the productivity in your organization. We use Microsoft Graph extensively in our own products. For example, in Outlook, it's the database that powers the drop-down menu, for example, in your email address when you address them. Or when you're picking files, it knows which files you've worked on most recently. In Teams, it describes all the channels and all of the chats that you have, as well as the communications that take place within them. So there's really a lot going on that's being captured in the Microsoft Graph. The thing that's really interesting about it is that we don't think that much about the ways in which it's changing how we're working inside of our own products. But it's actually powering all these little experiences that we have that are individually very, very helpful. There are all these little gestures everywhere around the product. But when we add them up at scale, they're collectively incredibly powerful.
And you've had the Microsoft Graph API for a while. I've used it, right? It allows, you can make a request, you can get, a calendar back, you can, like you say, you can interrogate an organizational hierarchy. So what's different about the API versus Microsoft Graph Data Connect?
Well,
the process.
We've always thought of APIs as being very transactional. You basically CRUD operations that you send and receive data from the API, and it's really small batch stuff. Right. It's requests at an individual basis or maybe at a batch basis. When you are talking about something like Microsoft Graph Data Connect, we're now talking about looking at data at scale, bulk volumes of data. The data, for example, from the entire history of your organization's time being in a Microsoft 365 tenant. So that's a very, very different way of thinking about the data that you have. But it comes, I think, with a set of very, very different obligations, right? Yep. The fact is that your organization's data at scale is sensitive, and you want to make sure that there's compliance built around it. You want to make sure that the complexity of extracting that data is abstracted as much as possible. You also want to make sure, though, that there's security and governance built around that. And these are all the things that we've had to think about. We have started to see customers really ask for the ability to look at data at this scale. And so even though we're just beginning to understand all the potential use cases for it, we do see opportunity in certain areas. For example, sales effectiveness is one of those areas, right? The ability to look not just at what's happening between, say, your customer service agents and the customers, to be able to look all the way down into your organization and get that really rich, 360-degree view of your organization. We also see that information security is a really interesting area when you talk about the ability to look at threats not just from the outside of your organization, but from the inside of your organization. The richness of this data really enables this. And I know this is the scenario that we're going to talk about a little more as we go forward. Process optimization is obviously a huge area where you can look at the way that information, data, communications are flowing through your organization. And of course, I think talent management is another place where we've always seen a lot of potential, sort of a who knows who or what the real organizational structure of your communications winds up looking like. Now it's time actually to turn things over to you a little bit, right? We've got the stage set, but the work that we've done together is actually incredibly interesting. So thanks for being here, and let's take a look at what you guys have been working on with us.
All right. Thank you, Ben. So here's a simplified flow of the architecture that we've built around Microsoft Graph Data Connect. So Microsoft Graph Data Connect uses Azure Data Factory to export data in bulk to Azure Storage. From there, we have pipelines that pre-process this communications content, and we're using Azure Cognitive Services to perform NLP, natural language processing operations on the data before we load it into Neo4j. And then that data is loaded into Neo4j, and we've built a canonical data model that we're leveraging that represents Microsoft Graph Data Connect and all of the entities that you can extract from that data. We'll look at that in just a second. And then we run Neo4j graph data science algorithms on the data so that we can infer things about the data and get deeper insights. Neo4j provides a variety of ways that the data can be surfaced for analysis. So we're going to look at Bloom visualization. We have an ODBC connector that allows you to connect to Power BI. There's a Python driver, so data scientists could directly interact with the Neo4j database using common tools like Jupyter. And of course, we have a rich set of APIs like GraphQL, which we'll take a look at, that can support web and mobile applications for real-time analysis and alerting based off of the Microsoft Graph Data Connect data.
Yeah, and the thing that I really like about this, and the thing that's so interesting about what I think we've done here is that, we've taken three huge assets really here, right? You've got your Microsoft 365 investment, you've got your Azure investment, and your Neo4j investment, and we're extracting, more data and getting even more value, I think, out of those three separate entities and bringing them all together here to do something that I think is really interesting, and it's going to be amazing. I think when people
it's a really nice story because with Microsoft Graph Data Connect, you get that comprehensive view of what your organization is talking about.
Right.
Across all the channels that are in play.
Mm-hmm.
You're able to look at that at scale. And then by bringing that data into Neo4j, which is you have a whole rich set of analytics that you can perform using the graph data model on this graph-based data.
Right. It's also interesting that, you can either do this as a sort of a greenfield project, right?
Mm-hmm.
Something where you just bring in the graph data, reason over it using all the tools that we've described. Or, if you already have a Neo4j database in place with a lot of other data sets, you can bring this in to make, sort of an additional level of richness apparent in the way that you're analyzing, the data that sits across your organization.
Exactly. That really is the core of this offering. So with these two technologies pulled together, essentially providing you a starter kit, and you'll be able to see your communications in a graph. But where you take that completely depends on your use case, and you can easily integrate other kinds of internal, external data and explore a whole number of use cases that we haven't even imagined yet. So one of the things that's really great about what we're doing and what we're collaborating on is that the shape of the Microsoft Graph Data Connect data itself is strictly uniform, which means we can build a canonical graph data model in Neo4j that extracts all of the main entities from the data and makes it easy to import the data into Neo4j. Some of the entities that we've extracted include things like person, Active Directory, email, Teams messages, calendar events. We can get to SharePoint documents, etc. And then we can take this model and we can enrich it using NLP-derived information such as phrase, entity, or sentiment. And then, of course, you can bring in any internal or external data that you want using this canonical data model as a starting point for building out your use case.
Yeah, it's pretty cool, and it's interesting to see that you've got raw graph data, derived data, as well as external data sources all coming together, and with the ability to sort of express the relationships between all of those things. That's what's really neat.
We've talked enough about the solution. So how about a quick demo?
Let's do it. Yeah.
So the demo time. Right? So the demo that we're going to do is we're going to run through a handful of demos built around this data security and compliance use case that Ben highlighted. And so we're going to look at things like watch terms, data leakage, integration with a real-time API, and then also we're going to show some visualization and reporting using standard enterprise reporting tools like Power BI. The data that we're using is from the open source Enron email corpus, which we've shaped to conform with the Microsoft Graph Data Connect canonical model that we just took a look at. And this data set contains about 500,000 emails representing communication between about 80,000 email addresses.
Yeah, it's pretty interesting, and the fact that we're using Enron, I think, makes it a little more interesting, but let's take a look.
All right, great, Ben. So the first demo that I want to show you is how we look at what are known as watch terms. So these are terms of interest in the communication stream. And so the application that I'm showing you right now is Neo4j's Bloom application, which is a data visualization tool that we have. It can render up to 10,000 nodes in a single canvas. And so the way Bloom works is you can explore terms, in an ad hoc basis and kind of construct queries and things like that. The way we're going to use it is the way an enterprise analyst might use it. So the database developers, the Cypher developers would have written a query, and then they can put it into Bloom, and then any analyst can access that query just using simple English and run that query. And so this is what we call the saved Cypher pane. And so we're going to run this query, and here you can see the query in Cypher. And so, these are parameterized queries that a developer could set up, and then the whole enterprise could then use this tool to access those published queries and run them.
And that's really establishing a set of related terms, essentially, right?
That's right.
Yeah.
And basically making the tool accessible to a large number of analysts within the organization.
Right.
And so, and you'll notice here, I just have to type a couple of characters, and it already finds the query that we want to run. And so here we'll take a look at emails by watch term.
Mm-hmm.
And so you can see it pulls up right out of the gate about 1,000 emails associated with different watch terms. And you can see here, these are the emails, and in orange, we have the different watch terms. Now that's a lot. This is a lot of data that's being pulled up. And so we want to narrow this down. And so what we can do is we can actually use the NLP categories for these different terms that we've established. Mm-hmm. And we can say, let's look at all terms under the legal umbrella. And so I'll go ahead and we'll put in legal here. And now you can see that we're dealing with quite a bit smaller amount of data. Let me just zoom out here. We can look at one of these subgraphs.
Mm-hmm.
And here, of course, you're seeing legal terms like attorney, right? Now, recall that we pre-processed all the data using Azure Cognitive Services, and we did a sentiment analysis.
Right.
So now what we can do is we can then filter not only on these category of terms, but also on the tone of the email. And so we'll go ahead and we'll filter this body down, this query down, and we'll find emails where not only are they in the legal category, but the tone of that email indicates some level of severity.
Right. And by severity, you essentially mean alarm, right? It's
Exactly.
the human tone of the email.
And so just to, put some color around this, recall that this is the Enron data set. And there's a bunch of emails, and the watch term here is investigation, and the sentiment is severe.
Right. Unsurprising.
Right.
Yeah. So what's next? So we've narrowed it down to a set of legal terms with a tone of severity that we've said was high. How do we start making this even more actionable? How do we drill in further?
Yeah, so not only can we look at the content of the communications, but we can actually look at the patterns of communication. And by that, I mean, what is the topology of this graph?
Right.
And so from an information security perspective, one of the use cases that is always of concern is exfiltration of confidential information outside of the corporate boundary.
Right.
And so the next use case we're going to look at is emails that have been sent to external recipients. And in this case, what we're focusing on is, and we can use the graph to really narrow these analyses, we want to find the communications where there's only external communications or communications that are being sent to a single external recipient. Yeah. And why that's important is if somebody's going to exfiltrate some information, typically the pattern is they'll send it to a external single account. They're not going to broadcast widely.
Right. Typically their own account, right?
Typically their own account, right?
Exactly.
So I'll run this query, and we'll get a view of who's talking to who, internal and external in the organization.
Right.
Okay, so the data is rendered here, and we can zoom into this graph, and what you'll see is that we've got red nodes and blue nodes, and so the blue nodes here represent the internal Enron email address.
Right.
And then the red node represents an email address that is an external email address. And remember, all of these individuals have sent some communication that has a negative sentiment
Right.
to a single external email address. And so from this pattern of information, we can scroll around in the graph here, and we can see, here's a very prolific set of communications. And you can also see, that there's some potentially confidential information being exchanged here. So in this case, there's an email where the subject line is Enron default swaps.
Right. Exactly.
Right?
Yeah. Which we know where that led. Yeah.
From a compliance perspective, maybe not a good thing. You can also see that there's email whose subject lines include things like rough drafts of documents and so forth.
And strategic plans, of course.
And strategic plans, right. And so with this capability, we can then look at the pattern of communication. And then as a final thing, we can actually look at how this communication evolves over time. And so we have the ability to basically play these communications forward. And so I can go ahead and do things like build this graph up over time, and you can see, basically who are the most prolific communicators, and the volume of their communications as time moves forward.
And I would imagine, too, you can zoom in on anomalous activity or spikes as you see fit.
That's right, yeah. And so, for example, if we wanted to look at, what's sort of happening later in this Enron data set, we can zoom in on some particular piece of time, and we can see what people are talking about to their, external email addresses. And so here's, a set of emails around systemic risk, FBI investigation, and so forth.
The things you would expect to see.
The things that you would expect to see. So a very powerful capability, the ability to look at the sentiment, specific terms, and look at how that's evolving over time, as well as how different entities, both inside the company and outside the company, are in communication.
Yeah, it's really fascinating. Thanks for sharing that.
Yeah, you bet.
Yeah.
Our next demo is we're going to take a quick look at a API that is called GraphQL. And what GraphQL does is you write a simple query. It's a more modern API. And what we've done is we can do things like look at the cumulative number of exfiltrated emails.
And specifically here, I can see that you're, looking at that category legal that we saw earlier. So we want to understand the number of essentially a highly sensitive legal issue or topic-related emails that are coming out of the business.
That's right, yeah. And so you can see here that we're combining a couple of different themes, right? So we've got sentiment analysis, we have entity extraction happening in the email, and then we're also accumulating against this pattern of exfiltration. And so I run this quick query, and now you can see here I have individuals, and we're showing not only the number of emails that they forwarded internally, but the number of emails that they forwarded to external addresses across a set of categories. And so here we're focusing on the ones that are categorized as legal.
Right.
And so you can imagine that this type of a query being executed through an API, you could then be polling your Microsoft Graph Data Connect graph, every 2 minutes, every 5 minutes, looking for changes, and then being able to raise that into an alert. Now, the last demo that I want to show you is we have an ODBC connector for Neo4j. And so what we can do with this is now you can actually take this data and distribute it through your standard enterprise reporting tools like Power BI.
Right.
And so here, this is an example report of leakage activity that maybe the CISO would want to look at as like a dashboard or something like that. Maybe a forensics team or something. And you can see here that now we're just showing things like, here's the number of emails sent by a particular individual. Here's the distribution based on our entity extraction using cognitive services of what those emails were about. And you could do things, like combine the categories or look at severity or so forth. But the point I'm making here is that we can actually take this data, pull it all the way through into tools that are already widely adopted within the organization.
Right. And because I think the data coming out is sometimes as sensitive as the data going in, we continue to maintain the compliance and privacy boundaries of 365, at least with, when we use a tool like Power BI.
That's right. And you would have, a named user group that has certain access privileges that would be able to run this report.
Yeah, that's really cool. It's very cool. Well, as I expected, that was a pretty cool demo.
Thanks, Ben.
Yeah, we are excited to share this analytical offering.
It's still early days, but we have the basic components in place. Microsoft Graph Data Connect, core Azure services, and the Neo4j Graph Data Platform, which is available on the Azure Marketplace. As part of the offering, we're going to be providing a handful of code accelerators to help you get started with your use case.
Yeah, and what I think is particularly interesting and cool about this is that we focused on security in this particular demonstration and in this presentation, but we know that there are so many other interesting ways in which you can leverage the Microsoft Graph Data Connect data and the Neo4j tools that you have. Now, if you're interested in understanding the patterns of communication inside your company, please reach out and let's see how we can help you with this powerful combined offering.
We're really excited to see where our customers and partners take this technology. There's just so many interesting possibilities. Thanks for watching, and see you next time.